We're testing quantum communications in space, and it could change how Earth and spacecraft talk forever. I'm Chloe, your everyday STEMinist, and today we're talking about a tiny experiment on the ISS with huge implications. On the outside of the International Space Station right now is a shoebox-sized experiment called SEEQ. That's the Space Entanglement and Annealing Quantum Experiment. It's not just another sensor or telescope. It's a device designed to test whether we can use quantum entanglement to send information in a way that's fundamentally different from today's systems. Now, at the heart of this is a strange quantum phenomenon called entanglement. When two particles, like photons, are entangled, the properties are linked no matter how far apart they are. Change one and the other responds instantly, like cosmic twins. Einstein famously called this spooky action at a distance. And it's exactly what SEEQ is trying to harness. On Earth, quantum communication gets tricky over long distances, because signals can degrade or get lost. But in space, there's no atmosphere to interfere and light travels freely. That's why the ISS is the perfect testbed. SEEQ's goal is to prove we can generate and detect entangled photons in orbit, and that those quantum signals can survive the rigors of space, radiation, vacuum, all of that. Now, the experiment is trying two breakthrough technologies: creating entangled photon pairs in a very tiny space, and using a laser to self-heal the detectors when space radiation damages them. Radiation in space can degrade sensitive quantum detectors, which would wreck a quantum link. So the ability to anneal or repair them with lasers could dramatically extend quantum hardware lifetimes. Okay, this might sound a bit esoteric, but the implications are huge. Imagine a quantum internet, ultra-secure communication where eavesdropping becomes impossible. Better global quantum networks linking quantum computers. Spacecraft and Earth stations talking with unprecedented speed and security. And even more sensitive quantum sensors for science and navigation. And here's the thing I love about this story. For decades, quantum was a lab curiosity. Now we're taking that lab, putting it in orbit, and testing whether it works when nothing else does. And if you want more science that connects the weirdest physics with the world we live in, drop me a follow.